So what we want to look at in this video is the idea of speed and velocity. So speed is essentially a measure of the rate at which you change your location or your position. So if you think of being on some type of line and you start here and you then move, let's say, somewhere else. So after some time later, you're now over here. And the idea is, if you mark some point in time, so let's just call this time 1. And at time 1, you could mark your location as position 1 here. And then some point later in time, you're now over here. So at time 2, you're over here at position 2. And so what happens is, when you're thinking about your speed, you could think of your speed, if we're thinking of speed as being some rate at which you change location. You change position or location. Then one way you could measure your speed is you could think of speed as being the change of your position in time. So it would be essentially position 2 minus position 1 divided by the change in the time it took you to make that. So time 2 minus time 1. So essentially, you could think of your speed as your change in position over your change in time. So if you move from position 1 to position 2, and you do that in a short period of time, that means your speed is large. But if you move from position 1 to position 2, and it takes you a long time, then as time gets large, for the same position change, your speed goes down. So what you can think about, now we can move this to an example. If this is your home, let's say, and then you went over here and this is school or work. School or work, let's say. Well, if you mark position 1 as your home, and you say position 1 equals 0, so you mark this is the location you're going to measure everything against. And initially, you don't start timing, at some weird time, but time 1 is going to be 0. Then what happens is, what do you normally do? Whenever you drive somewhere, you say, well, position 1 is my house, and I'll start my stopwatch there. You then make a rough estimate of how long it takes you to get somewhere relative to your house, right? And so position 2, let's say, is school or work, and we'll use relative terms. Let's say position 2 is 2 miles away. And so, you're lucky you live, well, all right, we'll make it a little, let's say it's 5 miles. So position 2 is 5 miles away. And let's say on a given day, it takes you 20 minutes to get to work or school. Well, then what would your speed be? Your speed is this rate at which you change your location. So when we're looking, your speed in this case, let's change markers real quick. Your speed would be 5 minus 0 over, let's convert this is like 0.3 of an hour. So 0.33 of an hour minus 0, which is 5 divided by 0.33 which is like 500 over 33 is about 1.5. So this is approximately like 1.5. Let's go. Yeah, it's 15 miles per hour. And so when we're looking at our speed is just relative to the position you change and in the rate at which you change it. Now, let's say on another given day, you come along, and on some other given day, it takes there's a little bit of traffic or something, and it takes you, instead of 20 minutes, it takes you 30 minutes. So what happens to your speed? Your speed then is still 5 minus 0, but instead of 20 minutes, it's 30, so you divide by 0.5, and your speed is essentially gone down. So now your speed is 5 over 0.5, and this is now 10 miles per hour. So as the amount of time goes up, your speed would go down for the same given distance, which makes sense. Now, what we haven't talked about, this speed that we're talking about right here, this is actually the average speed. So your average speed, when we want to talk about a definition, your average speed, we'll get this one. Your speed average is just this change in position. Okay. Your average speed, right here, your speed average is actually this change in position. So it's position 2 minus position 1 over T2 minus T1. So it's the change, but this is your average because all we were doing is looking from beginning and end points. We didn't talk about what happened in between. All we talked about was beginning and end. So when you're only looking at the beginning point and the end point, then that becomes the total distance was 5 miles. The total time, let's say, was the 20 minutes. Now, in general, when you talk about just beginning and ends, like total distance, so this is like total distance over total time. And when you talk about that, when you talk about total distance over total time, that's your average speed. We had no information of what went on in between. So the difference between the speed average and the instantaneous is this. The instantaneous didn't account for the fact that on your trek to school or work, you stopped here and you went in and got some cup of coffee on your way to work. And that, so you basically came along, you were moving, you stopped, and then you continued your trek. And then actually somewhere else over here, you stopped and you talked to a friend. And, your friend home. And you stop and talk to your friend, and then you finally made it to work. And, you had your cup of coffee, but you drank it and you threw away the cup. But the idea is, you have no information about what occurred when you're looking at the average speed, but in reality, your speed along the way changed because you were walking, you stopped, you sped back, you sped back up, you stopped, you sped back up. And so your velocity or your speed was changing throughout the trip. And so you can think of your instantaneous speed, your speed instantaneous, as your speed at any moment in time. So another way to think about your instantaneous speed would be is if you went and took a road trip, and so let's say you drove from your house to your grandmother's house, or to the grocery store. Well, along the way, what happens when you're driving to the grocery store or a friend's house or wherever? You get in your car and you start driving. Well, your speed changes throughout the trip because you hit different speed zones. The speed limit may change. You hit stop signs, you hit red lights, you get stuck behind other cars. And so your average is taking total distance divided by the time. Your instantaneous speed is you looking down at your speedometer at any given moment and reading the speedometer. So at one point in the trip, your speed could be 25. When you're sitting at the red light, your speed is 0. When you get on the highway, your speed is 55. Getting off the highway, you're decelerating, your car is slowing down, your speed is 35. So your speed is constantly going up and down throughout the trip. And whenever you're looking down on your speedometer, that's your instantaneous speed. Your average speed is saying, well, the location was 5 miles away and it took me 20 minutes to get there. It didn't account for anything that occurred during the trip. So that's kind of the idea of speed. And there's two we can talk about, your average speed and your instantaneous speed. So the other part that we need to talk about is the idea of velocity. And so we'll just introduce the word velocity. And essentially velocity is this. It's speed with a direction. And because it's speed with a direction, this makes velocity a vector quantity. So it makes a difference if I'm going this way or this way. So direction makes a difference when you're talking about velocity. So when we're thinking that velocity is a vector, we need to think about the fact that because this is a vector and direction matters, we need to think about the fact that so like when we have a constant speed, we're maintaining 55 miles an hour, that's different than a constant velocity, because a constant velocity, if we have constant velocity means you do not change speed or direction. And so constant velocity means you do not change speed or direction. So velocity is a vector. Now we care about direction. So constant velocity means you do not change your speed or direction. So if you have a changing velocity, that means you change either your speed or your direction. And that's why velocity means you have to be careful. Like if you're moving, now when we talk about velocity, if during my trip I was walking this way at 5 miles per hour, and then I stopped and I turned around and went this way at 2 miles per hour, one of these, this would be like plus 5 miles per hour, and this is minus, because the one direction is positive and the other is negative. So you now have to make sure that you're keeping track of your direction, because your direction makes a difference. when you're looking at your velocity. And when you're changing velocity, you change speed or direction. So if I was moving at 5 miles an hour this way and I change my velocity, I could slow down, let's say. So let's pretend I didn't turn around. But let's just say I slowed down then here, and now I moved at 3 miles an hour. Well, to go from 5 to 3 means I changed my speed. And that's one way you can change your velocity. So to change a constant velocity means you don't change speed or direction. You can change your velocity by changing speed or direction. So velocity is a vector, and we need to keep that in mind because in the future it's going to make a difference when we talk about other things. So remember that speed can be an average or an instantaneous, and velocity is a vector, which means we have to pay attention to not only speed, but direction as well. And a constant velocity means you do not change your speed or your direction.